Welcome to our online info session for Ashton College's Circuits and Robotics course. We're happy to have you joining us, whether it's through our Zoom webinar, our live Facebook stream, or our on-demand YouTube video. Welcome to you all. I'm Jake Cressy from Ashton's Marketing and Communications Department. I'm joined today by Maggie from the Admissions Department, Rika, who will be working in the background, and of course, our Circuits and Robotics course instructor, Sai. Sai, how are you?
I'm doing great. How are you guys?
Doing very well. I'm excited to get started here. Now, just some housekeeping before we get underway. We're going to have an open Q&A section near the end of the live stream where members of the audience can submit your questions for Sai to answer. If you're with us on Zoom, you can use the raise hand function or simply type your question into the chat box. If you're on Facebook, you can write your questions in the comment section and we'll be sure to take a look at them there. If you have a very specific question or if we don't get around to answering it during the session, you can email us at ceinfo@ashtoncollege.ca or you can call us at 604-891-1256 or use our toll-free line 1-866-759-6006. Now, before we get into the meat of the course and what it's all about, Sai, I'd like to ask you to share a little about your experience, your educational background, and what brought you to teaching with Ashton.
Yeah, sure, Jake. So I came to Canada 2 years back, but before this, I used to be a robotics product developer back in India. So even though I was a mechanical engineer, I was very much into technology, and because of that reason, I started looking into the alternatives other than mechanical engineering in order to develop custom new projects. So I integrated mechanical engineering to electronics. So through mechatronics, I started developing various prototypes to solve advanced technology problems that are arising these days. So I saw that there is a huge market for that, and I encountered with this company called as Robotics, which works for industrial automation and defense technology. So even though they were hugely into technology, the company also had a section in education sector, which was very in line with me. So I got very involved in educating students in robotics to give them a better future. So starting from then, I have been in the educational field and also in the automation industry field, working simultaneously together. And I'm really excited to see how this upcoming session for the robotics is going to go ahead.
Yeah, I think it's going to be very exciting. That's quite a rich background you have, starting from mechanical engineering. I'm curious, for this course, are there any prerequisites to get involved in this? Who should be enrolling in the Circuits and Robotics course?
Anyone who's a technology enthusiast who wants to learn how things around you work, who wants to learn what the current technology trends are, anyone can join. There are no prerequisites as long as you have enough enthusiasm. That's the only thing that we ask for. But even as we prolong in the session, the students will gain enough knowledge on the basics of electrical, mechanical, electronics, and computer programming to the very basic level. And then we're going to ramp up our pace from there, and we're going to build amazing projects. Yeah.
That sounds very exciting. Now, to bring it to the course outline, it's sort of broken down into 4 core topics. There's circuits, programming, electronics, and prototyping. Now, can you run us through each one of those and what they entail?
Yes. So as mentioned, the robotics itself is a multidisciplinary platform. So robotics, whenever you say robotics, it does involve electrical circuitry, which gives power to your circuit, electronics, which is controllers or the brain for your robot, and then programming, which gives knowledge or intelligence, artificial intelligence to your robot. And then finally, the aesthetics or the look of it, the mechanical design, which holds the robot and makes the necessary mechanisms to perform a specific operation. So as robotics is split into these 4 categories, students are going to start learning the fundamentals of each of them, starting from the basics of what is electricity, how does it flow through a battery, why does it come out of a battery, and how does it energizes the lights, bulbs, motors, and everything around us. So they start by testing out. So this entire course is 95% practical. So every concept that we discuss, students are going to test it out. So when we say, hey, electricity comes out as positive and negative poles, how do you know that? Let's try. So students start, build their circuits and test it out to see why is it more current in series, why is it more voltage in parallel. Everything students try and test it out. Similarly, for electronics, students are going to learn how does a controller store a program, how to retrieve a program, and how to write a program in a computer programming perspective, and in the end, how to build a project. Okay, so before we go ahead, I want to show you a small demo for a project that a small prototype that I made in order to show them how the end projects for the course looks like. So this is a small device that I designed for a home automation project made by the end of this course. So this project involves a bulb which works at 120 watts directly connected to the household power, and a 24-watt cooling fan, and a stepper motor which is used to open and close the door. So I'm considering this as a small house that students can build throughout their classes. So once you are done with the mechanical building, so this part is the mechanical building. Inside, there is a huge lot of circuitry going on which switches power from the 120-watt household power into 12-watt or 24-watt power for the motor, and into 5-volt power for the stepper motor driver, and finally the enough current for the controller to run. So we have done with the circuits, and then coming to the controller, you need to set up the controller, its operating system, its programming platform, and then students go for the programming end, where they develop their own web page and they write their own Python or Java programming in order to execute the command, in order to understand the environment. If you could give me a moment, I'm gonna show you a small web page that students are gonna develop. So this is a sample website that a basic student can develop. So I just call it Home Smart Home because it's a home automation project. And if you see, it's a very basic web page with a background image and various buttons to turn on things on and off in your house. So if you consider this as a regular house, instead of having this box, you have entire the circuitry in a panel inside your box. You don't need switches in your house. Okay, so you can turn on these lights and fans with your mobile, with your tablet, with your laptop, anything, wherever you are. You just log onto your Wi-Fi, get to the web page, and then you click on light on. You'll see your light on, light off, and then there's a small fan over here. It's a cooling fan that I used right now because I don't want to bring the entire fan down. It's not going to fit in the video. So have a small fan. There you go. And fan off. And we have a small door over here which mimics the actual door that we have at the front of the window. We can add more securities to open it, but for now, yeah. So these are some kinds of prototypes that students are going to make throughout the session at every part of it, and they're going to learn by building. Similarly, another such project is this gesture control robot, where this entire robot is controlled by a human gesture through the sensor. So we attach a small sensor to our gloves, and the sensor takes the inputs from your gestures, tells the programmer, and the logic that the students write will make the robot run in the house based on your gestures. It can be used as a smart vacuum cleaner. It can be used as a communication device. It can be used for various purposes. Yep. So these are some minor projects into the session, and during the session students are going to make a lot more projects for every concept that they're going to learn. You learn a concept, you make a project to check how that concept works. So it's both practical and theoretical, but 95% is the full-on practical sessions, which I believe students are going to love for it.
That sounds really excellent. Those are some exciting demos. I do have a few questions about them. First off being so you said they're going to be making multiple projects throughout the course of this. What materials and tools are they going to need for this course, and how much is that going to cost them?
Yes, initially we're going to start with the basics of circuits and robotics session, where students are going to use an Arduino kit and maybe the car kit, the car chassis that I just showed you. So they don't need any external tools. We're going to provide them a single link where they can order a single kit for Arduino, where they get all the electrical and electronic gadgets in, and we order one car chassis for the mechanical component. Whereas for the software end, most of them are the free to use open source softwares, which students can download online. So the Arduino kit costs around 30 to 60 CAD based on how much expertise they want. Students are flexible to go for the beyond, but we will tell them the prerequisites, which is around $30 to $60 it costs. Whereas once we go for the advanced sessions of robotics, students might order, we will go for Raspberry Pi. For the IoT project that we just saw for home automation, we use a Raspberry Pi small computer called as Raspberry Pi. And this also comes with, we need to order some prerequisites like the bulb and fan. Those doesn't come with the kit. Those students can purchase from their nearby hardware store, or they can buy them online too. We will provide them links for them. So that will cost around $60 to $100 for the entire kit. But this is not just a one-time kit. The use of this kit doesn't get low when the session is done. Students can still experiment, learn, and they can use the same kit for some projects that they can build for their own house automation.
That's fantastic. Now, you mentioned a term that I think maybe some people in the audience might not be familiar with, IoT. Could you elaborate on that term, please?
Definitely. IoT stands for Internet of Things. So it simply means connecting the things around you to internet. We have seen that in the past couple of generations, technology is trending very rapidly. And we also observed that a lot of gadgets around us, which are not previously connected to internet, are now Wi-Fi enabled. For example, mobile phones. Initially, mobile phones by default works with a SIM card. None of them were integrated to internet. Okay, these days, not just mobile phones, we are seeing that our home heater system is connected to internet. We see that our washing machines are connected to internet. We see our computers are connected to internet. Previously, computers are only used for calculation. So, right, starting from that day, now we have smartwatches connected to internet. So day by day, we are integrating more and more gadgets which we use in our daily life. We are connecting them to internet so that we could use them from any place that we want. We can trigger them at any time that we want, and we can get live data from them at every instance of our life. For example, if you want to monitor who's coming in and going out of your house, you just connect a camera to it, connect it to internet. You have a live feed of whoever's coming inside your house. If you have that door automatically triggered, then you can give them access online from wherever you are, right? So what students will learn through the course is, how do the things around you work? How do the gadgets around you work? How does a microwave work? How does a door actuation mechanism work? Or how does a smart watch work, right? So these are the things in the Internet of Things. Things are the regular gadgets that you use in your daily life. And then what students learn is, what is internet? How does internet work in the backend? What is IP address? What is internet protocol? What is secured shell scripting? So once they know what is internet, and how the gadgets work. They link internet and gadgets with the help of electronics and artificial intelligence. So once they make this link, they'll be able to communicate with all the gadgets around them using internet from any point of the world, at any end of the world. So that is the home automation project is a demo for the IoT, where you have lights, fans, and doors in your house, which you are actuating from a remote place using your mobile or tablet with the help of a web page. Yeah.
That's fascinating. Now, in terms of these projects they're building, the automated home and the gesture activated machine, where do those lie in terms of complexity of the projects we'll be completing? Are these ones they'll see in the earlier weeks of the course, or will these be later on?
So these will be structurally building this. So we start, as we said, we don't have any prerequisites for the course. The students start by learning the basics of every module. If we consider the gesture control robot, first we have a sensor called as gyro sensor to sense the movement of your hand. So initially students will learn, hey, how does the sensor take my signal? Okay, in my real life, do we have this sensor somewhere? Yes. Whenever you are using your mobile, you flick your mobile up to your ear to take a call, the screen turns off. When you're playing a temple run game or a subway run game, you tilt your phone, the person inside the mobile tilts. So my phone is able to sense my motion. So the same sensor which is in your phone now is in your hand. So students will learn, hey, how to receive a signal from this sensor, how to modify this signal to be able to use for my purpose, right? It doesn't have to be motion every time. It can be used to get me, like if I make an advanced robot where I can say, hey, get me juice, get me food, or bring me, do my homework, I'll write my homework in air, you write my homework on the paper, something like that. So students will learn from the basics of electrical point of view and electronics, the gadget point of view, and they'll learn the basics of programming, how to program these devices and how to build the mechanism that is required for this machine to run. So they go in a structural manner, step-by-step way. So at the end of every level, they're going to build a prototype to test their learnings. So throughout this project, the 36 hours course, students are going to make approximately 6 projects.
Okay, excellent. That's going to be spread throughout there. The next question then is, how much time should students be expecting to put into this class outside of the regularly scheduled class sessions?
I would say as much as they can, because this is an open platform. In general, you don't have to keep any of your hours after class. Everything for this course is done within the class. But if you're enthusiastic, that's a big world out there, and there are no limits for your imagination and for experimentation. So students can go on and out with their experimentation after class, which I recommend a lot. But for this session, they don't need any at home time that they need to spend. Everything that they do it in the session. But if they do it anything out, it'll be an added knowledge and added experience for them, which is very, very valuable.
Okay, so extracurricular activity is not required, but highly encouraged. Is that right?
Yes,
Excellent.
exactly.
Now, you've talked a lot about this being a practical course. Of course, this entire course is offered solely online. So you can talk about some of the advantages that the online class format might bring?
Yes, there are various advantages. The first thing, because this being a practical session, students will get a lot of hands-on. Whenever, as I have been in the educational field for the past 4 years, I realized that when a lecturer is beside a student, the student tends to get a little tensed up, and they always tend to make the professor or the lecturer do half of their project, right? Like, hey, if you're building it, if you're stuck somewhere, you're like, hey, I'm not getting this, can you come and help me out? And the lecturer tend to finish up half of the project, whereas the student does the other half. And I have been experimenting on these online sessions for the past 2 years. I realized that students, they have their dependability. Now they don't have anyone who they can rely on. So they start depending on themselves. They start thinking for themselves. This increases the critical thinking of a student a lot, because this is a practical session. As it is going on, students encounter a lot of hurdles that they need to cross. Hey, I made this circuit to turn on my light, but the light is not turning on. So what might be the reason? Did I write the program wrong? Did I make the circuit incorrect? Or did my bulb blow off? Is my gadgets working? So there are a lot of errors that might pop up. So students, as they're in their free space, they're at their home, they're at their free to take suggestions from their parents, they get to have their freedom, and they try to experiment more. As when they're in their classroom, they are restricted. They feel that they're restricted to what they do. They feel that they're restricted to what they can ask. But whereas in an online session, because students are away from me, they know that I can't say anything to them. They're like, hey, I already connected a light. Can I also connect a fan? Can I also connect a microwave to it? They start experimenting. They start putting things in, and they get more issues. They get more hurdles. When they get a hurdle, they try to overcome it, and they gain experience. So in this point of view, I realize that online platform is which used to be a very downhill path for a practical course, became a very advantageous situation for an enthusiastic kid to learn.
That sounds great. So you get all the advantages of having a teacher to guide you through without necessarily the disadvantages of having them do too much of the work for you. That's excellent. Now, my next question is, after students complete this course, how can they continue to build on the skills they've learned?
So as mentioned before, the room for experimentation and the heights that you can go with robotics is not limited. The world is trending. As I was in the automation field for the past 4 years. I've been experiencing various trend changes in the technology in the outer world, whereas I've also seen that the exact same trend is coming up in the educational field. So for example, right now I'm working for an automated grocery store that works around Toronto region, where we have thousands of robots that are picking and packing groceries for our customers every day. So I've seen that these automation robots are using Internet of Things in order to take orders from online, and they're going to integrate it. They're going to pick the products using electronics and robotics, and they're going to package it and send it back to the customers. I've seen that there is a huge change in how people used to do grocery automation before. Now even grocery automation is linked to internet. As I thought, hey, now there's a huge gap between industry and education sector. But now what's happening, they're introducing more and more gadgets in the educational field to be able to cope up with the industry. As long as students have the right guidance and the right equipment, they will be future ready. They'll be even more than ready to be a researcher or a scientific developer in the upcoming robotics trending environment. So the limits to this is boundless. Students can go beyond, above and beyond, and I'm really looking forward to what my students become.
That sounds very good. Now, what are some of the most common uses, or maybe the most common fields that are using robotics at the moment?
Yes, so students who are taking a robotics course are not restricted to a specific field of engineering. That is one of the greatest advantage of robotics field. As we mentioned that the robotics field is a combination of electrical, electronics, mechanical, and computer science. Once a student learns this course, once they experiment on it, and once they build on it on their own, they'll be confident in themselves to decide, okay, now I'm going into an engineering field, right? So which department of engineering should I go through? Hey, I feel that I'm good at programming, I'm good at developing websites. I'll go into an IT field, information technology field. I'm good at developing the web pages, making them look nice, making them look pretty, or making them more accessible. I'll go into UX and UI, user interface design field. Hey, I'm good at making a circuits and building something practical. They'll go into electrical field. Hey, I love how technology trends. I want to learn how the sensors, motors, actuators, and the gadgets work. They'll go into electronics. And people who want to build up the mechanics and build up machines, they'll go into mechanical field. They'll get an idea of what their future is gonna like. And at the same time, the students who learn this will have a huge growth in their specific department, as they started as a mechanical engineer, but they have knowledge on programming and electronics. So they can add it up to their mechanical field, and they could go into the industry as an advanced technician who is familiar with the current trends of technology. So students have a wide range of scope that they can go to. And once they are in their specific field, they have a wide range to grow in their specific field to automate that specific one.
Right. So it seems like robotics is a really good foundational knowledge that you can use to specialize in a lot of different areas. That's
Yes, it will
fantastic.
be a really good stepping stone for the students who are entering into the engineering field or just coming out of the engineering field and trying to go into an industry.
Excellent. Now, you've mentioned you've been in the industry for quite some time. How have you noticed the industry change during your time in it, and what sort of changes are you anticipating in the future for robotics?
Uh, Honestly, in the last couple of years, the trend growth has been exponential. I've seen that from a point of view where people has never thought that grocery shopping will be automated, online shopping would be automated, like household activities would be automated. No one has thought that these things have a scope in our future. I've seen that even people's perspectives of realizing what can be done and cannot be done has been evolving in a very rapid pace. Uh, Previously, the robotics platform, which is kind of stuck with medical and defense, that used to be a primary action section for robotics. Whenever someone develops something new, the first implementation is going to be in the medical field to save someone, or in the defense field to protect ourselves from others. So these used to be the prime and only applications for robotics industry. But in the last couple of years, the robotics has spread its wings into every single field of automation. It has spread into household applications, agriculture, business, cosmetics, online, grocery, and not one and not two. They're like each and every field that has that people think that, hey, this can't be automated. Grocery shopping cannot be automated. Come on. I need to go. I need to see how my vegetables are. I need to decide how they are. Starting from that phase, now it is automated to such a way that in this critical times during this COVID, people are feeling very comfortable using an online platform where robots pick and pack for you in a most efficient way and get it back to you in hours. So it has been helping people in these tough times, and it has been changing the mindsets of people of how things can be. So in future, I'm also expecting great prospectors where students and industries as well will have a lot to focus on, lot to experiment on, and I'm expecting for a very advanced and interesting future.
That's excellent. Now, we talked earlier about using programming. That's a big part of the course, is learning and using programming languages. What are some of the most popular programming languages in robotics?
So the initial phase of robotics, circuits and robotics, when we go for, it's going to use basic C++ language to build on embedded programming. So initially what they learn is, we call it embedded programming, because it is not just, when you say programming, it is a programming that you write to see an output on the screen. But whereas the program that we write it to see output live running in front of your eyes. So we use initially C++, which runs in background. We use it uses a little bit Java scripting to build up on. So as we progress on, initially we start with C++ to help students learn the basics of programming language. So once they're good with basics, when you want to go for advanced projects, you want to build on IoT, you want to build a web page, you need to learn HTML. So students will learn HTML to build their own web page. And in order to integrate that HTML to your C++, you use Python interface. So for IoT projects, Python is the most flexible and most interactive software that students use for. So you use Python for IoT and HTML for your web designs, and you use C++ for your embedded circuit programming. So as the level goes on, the student's scope of learning different programming languages increases.
Excellent. And is that the same programs they should expect to use in the professional world?
Exactly, exactly. They build on this exact same programming platforms, but the basics that they learn over here is being carried forward through their entire life, not just in their technical field, even in their personal life, where they want to teach their kids how things work, or they want to build something for their own knowledge or growth. It's going to help them in every aspect of their life from here.
Excellent. So what are some of the biggest challenges that people in this line of work face?
First thing, because it's a multidisciplinary field, people feel that, hey, this is a lot to take in. I cannot deal with electronics, electrical, programming, and mechanical building, all of them at the same time. So initially, people feel that it is a lot of stressful, but the course is designed in such a way that it's more fun than me being more intimidating. So it goes in a fun-filled fashion where students will get to uh, test out everything that they do. So you write a program, you don't know how it works, you test it out. You write something, you test it out. So it's going to be a very fun-filled session. So the first challenge that they face is multidisciplinary. So people need to come out of their box in order to realize that, hey, if the person is a programmer by himself, they believe, hey, program is used to see my output on the screen, right? Now they need to come out of their box to think that, hey, when I'm writing for a program for an electrical circuit, it is different from writing a program to see an output on a screen. So it is a discipline change that they need to look after, and it takes a lot of time in order to build your fundamentals. So we are planning to offer this course in various levels, um, various levels, where initial level is going to be in a lesser phase. We're going to go in a slow pace, learning the basics of every single module of robotics. Whereas once we go on, we are planning to introduce more courses on IoT, application development, and advanced robotics, where students can opt for after going through the first initial phases of basics of robotics. So I want students to be patient, because it's not a one night thing where you can master all four fields of robotics in a single night. So it's going to take time. That is why we're going to go very slow, and we're going to go at a very enthusiastic pace, enough for you to experiment and have fun.
Excellent. Now, you've mentioned one of the big challenges, interdisciplinary and a lot of information to take in. Of course, with things in the technology industry, there's also a constant, rapid, evolving industry. Things are always changing. So how do you stay relevant in this field? Are there any information sources you'd recommend people look to stay up to date?
I would recommend TED Talks. TED Talks is one of the very good platform for students or any enthusiast to see what is trending at this point of time. See, when we say what is trending, it doesn't mean that it is something completely new. For example, if we got a new programming platform called as Spunk, for example. So Spunk is an advancement which came from Python or some other relevant programming field. So it is not something that is really new that you need to learn from the scratch. It is something that you build on from what you are right now. So the trends that are coming up are something that people need to look after, but they don't have to fear it. So you just need to look after and you need to realize, hey, what is it being built on? What are the advantages of it? What are the disadvantages of it? When you're going for something advanced, you're also losing some freedom in it. So that is why even the JavaScripting is a very old platform. We still use JavaScripting because it gives us more flexibility to do things that the new software such as .NET or Python cannot give you.
Okay. So, and by learning these old ones, the fundamentals, JavaScript, C++, when these new advancements come along, students will be able to sort of easily trace the roots and say, well, this is just a progression on Python. This is just JavaScript, but with this kind of twist. Excellent.
Yes, exactly. And it also, there's one of the biggest advantages of this course is as per the university's research on how students take in education, it believes that once a student knows a little bit of what a lecturer is teaching, they feel more enthusiastic to learn it or progress in that diversion. For example, when I was a kid, I was very much interested in the inventions, right? I used to analyze, I used to imagine how things work. Like I used to see a car, I was like, hey, I don't know how this is working, but I think it works in this way, this way, this way, right? When you have a thought perspective and when you have this in mind, and when a lecturer comes to a class and says, you might have seen a cars running around in your house these days. Have you ever imagined how it works? Then that catches the student's imagination. A student who's not that much interested in classes and he is diverted will get indulged into the classes because he knows what is the root of it. He knows that, hey, this is some topic that I have a basic idea on. They feel like, hey, if I work a little, I can stand out in my class because I already know this topic where others are not much familiar with. This is some research that is very interesting research that someone carried out, which I realized that it was also a very important thought realization that I came across in my childhood.
That's excellent. Now we're getting close to the end of our interview. I'd like to ask you, there's a lot of educational paths out there. Plenty of people are offering similar courses from different institutions. Why should students choose to take this specific course with Ashton College?
With Ashton College, we kept tremendous research behind developing the structure of this course. As mentioned before, we're going to offer this course in multiple levels to be able for the students to be flexible for the students who are intending to grow along with the course. So the course deployment is segregated in such a way that it is not too aggressive for a student to learn things, and it is not too slow for someone to get demotivated on where they are going. So we kept tremendous research on developing the course content, and we have segregated it and arranged it in such a way that it's going to give them the exact right amount of pace that will help them progress in their future, not only in terms of robotics, but also in terms of any technical learning. It will tell them anything that you learn, this is how you need to go forward when you're learning something.
Excellent. Thank you for that. Now, before we get into the open Q&A section, we're going to talk briefly about the admission requirements for this, when people can register, when the upcoming courses, and to guide us through that is Maggie from the admissions department. Hi, Maggie.
Hi, Jay. Thank you for that. Again, this is Maggie, admissions officer for Ashton College Continuing Education Division. I must say it's a timely and suitable course that we have to offer in this modern world. Thank you, Sai, for sharing this wonderful information to all of us. To our potential students out there, if you are a robotics enthusiast, the Circuits and Robotics course will help build social, professional, and technical skills, which will assist the students in their upcoming futures in the robotics world. I've also realized that new homeowners will also benefit from taking the course. That start home is a must try, hey? We have a start date on March 9 till May 25, March 9 till May 25, 2021. The interactive classes will take place live online. And yes, students will have a chance to ask questions anytime during the lecture. As we know the importance of Q&As during lectures, right? The course duration is 12 weeks, as the instructor already mentioned, with a total of 36 hours of instruction. It's a once a week that is every Tuesday from 4 p.m. till 7 Pacific Standard Time, 3 hours of live instruction each week. We have no prerequisites for admissions. There is no textbook required. You only need to pay the registration fee of $820, and that's it. You will be automatically enrolled. Your questions are important to us, so for further assistance, you may contact me at 604-891-1256 or send me an email at ceinfo@ashtoncollege.ca. Thank you, Jake.
Thanks, Maggie. All right, the floor is now open to the audience members for any questions. Rika is looking after those, so I'll turn to you, Rika. Are there any questions?
Yes, I guess we have one from Nathan.
Yes, go ahead, Nathan. I am giving you mic access, and I think you just need to unmute yourself.
Hi, Nathan. Nathan, can you hear me?
Yeah.
Yeah, Nathan, go ahead. What's your question?
So my question was, when you learn those languages, what can you apply it to, like in your life?
So the application for these languages, initially, this course doesn't just give you an intro to how a programming language works. It will also give you a flexibility to use your program in multiple fields. For example, when you look at an IoT project that I just demonstrated, throughout the project, you are going to do multiple levels of programming. You're going to do HTML program to see how your website works. Because you learn how to make a web page, you can build onto that and you can work for a company like Facebook or YouTube, where you can add database to that HTML and you can emphasize on it to go in an IT sector. Whereas if you want to emphasize on the C++ programming that we write for electronics, you can go in the embedded field or such called as machine learning, and then you can go ahead from there to write programs to build robots or make electronic gadgets work. Okay, whereas when we are looking at Python JavaScripting for intercommunication between a web page and an embedded device, you can use that for artificial intelligence, where Python is one of the main source for artificial intelligence and machine learning. So you can build on from there to build your own AI, own artificial intelligence, or own communication interface that connects things together. So you are exposed to multiple fields, and we're going to learn the basics of each and every one of them. That'll help you decide which field do you want to go into.
Oh, okay. Thank you.
All right, are there any other questions from the audience?
Hi, Jake. Yes, we do. So we just have a question from Facebook. And the question is, I'm changing careers and have no prior background or experience in engineering or mechatronics. Am I going to have a tough time in this course?
No, definitely not. So, as mentioned, there are no prerequisites for this course. As long as you are enthusiastic enough to learn, that's the only thing that you will need. Because uh, because it is very important for people who are changing careers. This is the right platform, because right now when you are trying to change your career, you might be confused to which field to go in, to see which field has more prospectors for me, or to realize which field you are more comfortable with. I believe that this is the perfect platform for you, where you get exposed to multiple fields and you get to learn the basics of everything. And the course is designed on based on a lot of research that we kept in previously, so that everyone who's coming in is going to have the basics for every single field that you're going to go into. So I believe it is a really good option for career changes, because it gives you an insight to diverse fields and gets you through a very basic phase of each one of them, so that you'll be comfortable enough and you'll be having enough knowledge to choose your next path for career.
Sounds
Excellent.
good. Thank you.
Rika, any further questions?
That's all the questions that I have. Thank you, Jake and Sai.
Excellent. Now, Sai, we're coming to the end of this. Is there any final thoughts, any final words of advice you'd love to give the audience? Anything you'd like to say that we haven't given you the chance to say so far?
Nothing specific. I just want everyone to be enthusiastic, always be hungry, be foolish, try to learn every instant. Yeah. So I'm really looking forward to meeting you guys during the further sessions. I'm guessing, Jake, we're gonna add more info sessions for the other levels of sessions as well in future. So I'm really hoping to meet my new students and get on with this new continuing education platform.
Yeah, beautiful. Some great closing words there. Thank you. So that brings us to the end of our info session. If you have any further questions, if you want to get in touch with us about anything we've talked about today or any other parts of the continuing education department, you can email us at ceinfo@ashtoncollege.ca. You can call us at 604-891-1256. We also have a toll-free number, which is 1-866-759-6006. Thank you all for joining us, and have a great day.